Hello everybody, welcome to our video tutorials. In this video we show you the features and functionalities of our LogicsManager, which is available in several power management products such as in the EasyGen 3000 XT Genset control. Purpose-built power management controls often do require additional functions and more flexibility to meet individual customer requirements. The LogicsManager, in short LM, has been developed to give the user of EasyGen 3000 XT and other controls a handy tool to customize the logic for each individual configuration and operation. The binary status of discrete inputs, discrete outputs, internal conditions, alarms, and measured values can be combined to advanced logical functions. These logical functions can be used to initiate numerous operational functions, such as starting the generator in operation mode auto, to control operation of a fuel pump, to implement special control functions to the present application, and much more. Here on the left, for example, you can see the start request in auto, how the LogicsManager is visualized in Toolkit, and on the right-hand side how it looks when configuring the EasyGen control via the HMI parameter menu. Let us have a look at the structure of a LogicsManager. There can be up to 3 logical command or input variables. Furthermore, there is a sign configurable for each input. Then, after the sign there come 2 selectable logical operators. And finally, in addition there is configurable delay on and delay off time. Now a bit more details about the items of a LM. What is the command variables? A list of more than 500 variables and functions is provided for the command inputs. Examples of the configurable variables are generator under voltage limit 1 and 2, start, fail, and cooldown. These command variables are used to control the dedicated function or a relay output. Please refer to the section appendix in the technical manual. There is the full list of logical command variables available. The sign field can be used to invert the state of the input command or to fix its output to a logical true or false if that input is not used. Setting the sign to not state inverts the output of the command variable, i.e. from binary true to false or vice versa. Then there comes the operators 1 and 2. These are selectable logic gates of the usually known logical operators like AND, OR, XOR, and more to achieve the desired logical result and function. And then additionally, there can be put a delay on or delay off time for the resulting logical result. Here is an overview of all the 6 available logical operators in the LogicsManager, the different symbols, and for quick reference you can see the truth tables for each operator. Here we have an example exercise, for which we want to configure a logic, for controlling the charging of a battery. The BMS provides 2 discrete outputs which signals battery status low and battery status high. Furthermore, the BMS has a discrete input that activates start charging when the input is active. If input turns false, the battery charger stops. What do we need in our EasyGen for that task? We need to configure 2 discrete inputs and 1 discrete output. Then it needs an appropriate logic that shall react on the incoming discrete signals, and the logic shall control the discrete output to control the charging. In order to keep better overview about the applied logical combinations, it is a good idea to use the internal flags to prepare some states which then shall be used in the logic of the relay output. Let us start by configuring the required discrete inputs. Here in this example, we use input 21 and 22. Configure the parameters as desired. Type a suitable description for that input in order to quickly understand the functions later. Important for this task is to set the alarm class to control, as we just want to use that signal for control purpose. Not to get an alarm message. In same manner, configure the discrete input 22. As next we decided to use 2 internal flags to latch the low and high state of charge signals. As by time the battery high signal will turn off, because it discharges after some time and falls, for example, below 90%. We want to charge the battery only if the battery low signal triggers. This may be if the state of charge falls, for example, below 30%. Similarly, As for the high state, we want to keep the low state and let the battery charge again until the battery reaches its high status. Click the Edit button of flag 1. A new window opens and shows the LogicsManager. To select a command variable, click the line to see the drop-down list of variables. You can scroll up and down to find the desired variable. If you already know the group where the variable belongs to, then just type the number on your keyboard and the list will move to the first entry in that group. For example, here we type 09, this is the group of the discrete inputs. Select the discrete input 21 here. The input shall lead directly to the operator, therefore we leave the line as it is. The first operator we change to an OR. The second variable we choose the logical status of the flag 1. As the variable also shall lead directly to the operator, we leave the line as is. With the first two variables and the OR operator, we want the logic to remain true even if the discrete input turns false. Now we need the third variable, which shall reset the logic to false state. This we want to achieve by means of discrete input 22. The sign must be not. The second operator is an AND. In other words, if battery low status becomes true, we latch that state by routing the LM flag 1 as an OR. The flag 1 now remains true until the battery high state becomes true. As next, the flag 2 is configured in same manner to latch the battery high state. Select discrete input 22 for first command variable, and OR for first operator, LM flag 2 for second command variable, then AND for second operator, at last discrete input 21 for third command variable with a not sign. Then, it needs to configure the relay output, which shall command start and stop for charging the battery. For this task we selected relay 17. The relay shall only energize if flag 1 is true and the flag 2 is not true. We choose the line, as flag 1 shall go directly into the logic. As first command variable we select the 96.01 LM flag 1. This is the logical output of flag 1. The first operator must be AND. Here, the second sign must be not, as we want the relay energize if only LM flag 1 is true and LM flag 2 not true. As we only use the first two variables in this logic, we leave the second operator as AND. As well, the third sign we leave as it is for always true. If necessary, you can add a little delay on and delay off. Click OK to save that LM. To prove if our logic and the relay behave correctly dependent on the discrete inputs, we can use the trend feature in Toolkit to visualize the signals and states. You can add several analog or binary values and trend these simultaneously. In our example, we want to watch the states of flag 1, flag 2, relay 17, discrete inputs 21 and 22. Select all these items by right-click and add to trend. The trending window opens in the background when adding the first value. After selecting all required values, switch to the trend window. The selected items are listed and have already assigned colors for the plots. For the initial state, we assume that the battery is in high condition. To which discrete input 22 is true and discrete input 21 is false. The recording starts by clicking the Start button. The sequence here shows how the discrete input 22 turns to false, as the battery discharges after some time and leaves the high state. Flag 1 remains true until the battery discharges further and its state changes to low. This means the discrete input 21 turns true. And now, after the configured delay on time, the relay 17 energizes to start charging the battery. After a period of time, the discrete input 22 indicates that the battery state is high again. The relay 17 de-energizes. The flag 2 latches to true. At these same conditions we started this sequence, therefore we stop the trending here. If you want to look more into the details of the trend, you can select the according time frame with the sliders below. If necessary, you can change the mean and max level of the plots, for example, to see clearly the lines, when for example trending 2 or more signals. For additional information about Woodward devices, including manuals, software, compliance certificates, and other documentation, please visit our documentation server. This resource provides everything you need to support the configuration, operation, and maintenance of your Woodward products. This is all for now. Please make sure to check our other video tutorials.